Hello students, welcome in 10th standard. Subject Science and Technology Part 1. In this subject, we are going to study about 10 most important chapters. So today, we are going to start our chapter number first, Gravitation. So in this chapter, we are going to study about 7 different subtopics. That is subtopic number 1, gravitation. Number 2, circular motion and centripetal force. Number 3, Kepler's laws. Number 4, Newton's universal law of gravitation. Number 5, acceleration due to the gravitational force of the earth. Number 6, free fall. And the last one, escape velocity. So at the beginning of this chapter, there is a can you recall? And in this can you recall, there are 3 questions. Question number first, what are the effects of a force acting on an object? So we know that student, when we apply force on any object, it can cause displacement of that object. Also, this force can cause change in the shape of the object. Also, we can change the size of the object. Also, we can change the direction of motion of the object due to the applied force. Question number second, what types of forces are you familiar with? So we know that student, we have studied about different kinds of forces. That is the muscular force, mechanical force, gravitational force, magnetic force, frictional force, and electrostatic force. In ninth standard, we have studied two more categories of forces, that is balanced force and unbalanced force. Question number 3. What do you know about the gravitational force? So, we know that student, this gravitational force, it is nothing but the force which is applied by the earth to pull the object towards itself. So that is why it is known as gravitational force. So we know that student, as we have studied in previous standard, this gravitational force, it is a universal force. It means it acts in all over the universe, and it acts not only between the two objects on the earth but also between any two objects in the universe. So we know that this gravitation or this gravitational force, it was discovered by the Sir Isaac Newton. So as the story goes, he discovered the force by seeing an apple fall from a tree on the ground. He wondered why all the apples fall vertically downward and not at an angle to the vertical. So, why do they not fly off in a horizontal direction? So, after much thought, he came to the conclusion that the earth must be attracting the apple toward itself, and this attractive force must be directed towards the center of the earth. The direction from the apple on the tree to the center of the earth, it is the vertical direction, and thus the apple falls vertically downwards. So in this figure number 1.1, concept of the gravitational force and the gravitational force between the earth and the moon, we can see that there is an apple tree on the earth. The force on an apple on the tree, it is towards the center of the earth, that is along the perpendicular from the position of the apple to the surface of the earth. This figure also shows the gravitational force between the earth and the moon. The distances in the figure, it is not according to the scale. Newton thought that if the force of gravitation acts on apples on the tree at a different heights from the surface of the earth, can it also act on objects at even greater heights, much further away from the earth? Like, for example, the moon. Can it act on even further objects like other planets and the sun? The answer is yes. This gravitational force acts on all the planets which are revolving around the sun, which are revolving around the earth. It means that this gravitational force, it is nothing but the force which is present in between any two objects in the universe. After that, let us study about the force and the motion. So we know that this force, it is very necessary to change the speed of the object as well as the direction of motion of an object. So there is a, can you recall, there is a one question, what are Newton's laws of motion? So we know that students, in ninth standard we have studied about the three Newton's laws of motion. Newton's first law of motion, it says that an object continues to remain at rest or in a state of uniform motion along a straight line unless an external unbalanced force acts on it. This was the Newton's first law of motion. After that, Newton's second law of motion. The rate of change of momentum is proportional to the applied force, and the change of momentum occurs in the direction of the force. Newton's third law of motion, it states that every action force has an equal and opposite reaction force which act simultaneously. After that, there is a introduction to scientists, and in this picture we can see that this great scientist, the name of this great scientist, that is the Sir Isaac Newton. So this picture is the Sir Isaac Newton. So this Sir Isaac Newton, he was born in 1642 and he was died on 1727. So he was one of the greatest scientists of recent time. He was born in England. He gave his laws of motion, equations of motion, and theory of gravity in his book Principia. Before this book was written, Kepler had given three laws describing the planetary motions. However, the reason why planets move in the way described by Kepler's laws was not known. Newton, with his theory of gravity, mathematically derived Kepler's laws. In addition to this, Newton did groundbreaking work in several areas, including light, heat, sound, and mathematics. He invented a new branch of mathematics, and this is called calculus, and it has wide ranging applications in physics and mathematics. He was the first scientist to construct a reflecting telescope. After that, let us study about the another subtopic, that is the circular motion and centripetal force. So to study what is meant by circular motion and what is meant by centripetal force, we have to do one activity. For this activity, we have to tie a stone to one end of a string, and we have to take the other end of the string in our hand and we have to rotate the string so that the stone moves along a circle that we can see in figure number 1.2a. So in this figure we can see that a girl is rotating a stone with a string. So during this position, can we apply any force on the stone, or the force which is acting on the stone, what is the direction of this force acting on it? So how will we stop this force from acting on it? What will be the effect on the stone? So the answers of this question we can give in this way, that is, as long as we are holding the string, we are pulling the stone towards us, that is, towards the center of the circle. So this is the direction of applying force on the stone, and it is towards the center of the circle. The force stops acting if we release the string, and in this case the stone will fly off along a straight line which is the tangent to the circle at the position of the stone when the string is released, and because that is the direction of its velocity at that instant of time. So from this activity we can understand that what is meant by centripetal force. So we can define the centripetal force, that is, a force acts on any object moving along a circle and it is directed towards the center of the circle. This is called the centripetal force. Centripetal means center seeking. That is, the object tries to go towards the center of the circle because of this force. So, so we know that students, the moon, which is the natural satellite of the earth, it goes round it in a definite orbit. The direction of motion of the moon as well as its speed constantly changing during this motion. Do you think some force is constantly acting on the moon? What must be the direction of this force? How would its motion have been if no such a force acted on it? Do the other planets in the solar system revolve around the sun in a similar fashion? Is a similar force acting on them? What must be its direction? So there are so many questions. So how can we give the answer of these questions? So from the above activity or the example and the questions, it is clear that for the moon to go around the earth, there must be a force which is exerted on the moon, and this force must be exerted by the earth, which attracts the moon toward itself. Similarly, the sun must be attracting the planets, including the earth, towards itself.